Welcome to Basic Technology for JSS 3. Today we study structural engineering, focusing on bridges and buildings. What is structural engineering? Structural engineering is a branch of civil engineering that deals with the design and analysis of structures, systems that support and transfer loads safely to the ground. The goal is to build structures that are strong enough, can bear the loads placed on them, stiff enough, don't deflect/deform too much, stable, don't fall over or collapse, and durable, last for a long time. Forces acting on structures. Structures must resist several types of forces: compression, a pushing force that tends to squeeze or shorten a member. Concrete is very strong in compression. Tension, a pulling force that tends to stretch or lengthen a member. Steel is very strong in tension. Shear, a sliding force that acts parallel to a surface. Torsion, a twisting force. Loads on structures. Dead load, the permanent weight of the structure itself, beams, columns, slabs, etc. Live load, temporary loads that change, people, furniture, vehicles, stored goods. Wind load, force of wind against the structure. Earthquake load, seismic load forces from earthquakes. Snow load, weight of snow, in cold climates. Bridges. A bridge is a structure built to span a gap over a river, road, valley, or other obstacle, and carry loads safely across it. The key challenge: transfer the load from the bridge deck, road surface, down to the supports, foundations, safely. Types of bridges. 1. Beam bridge, girder bridge, the simplest type. A horizontal beam spans between two supports, abutments. The beam carries the load in bending, top in compression, bottom in tension. Use for short spans. Example: simple road bridges. 2. Arch bridge, the load is transferred to the supports by a curved arch structure. The arch converts the load into compression in the arch itself. Arch bridges can span greater distances than simple beam bridges. Example: old stone bridges, the Zongaru Bridge in Nigeria. 3. Truss bridge, uses a framework of triangular units, or trusses, to support the bridge deck. Triangles are the most stable geometric shape, cannot be deformed without changing the length of a member. Members experience either tension or compression only, no bending. Efficient for long spans. 4. Suspension bridge, the bridge deck hangs from cables that are slung over tall towers and anchored to the ground at each end. Cables carry the load in tension. Very economical for very long spans. Example: Golden Gate Bridge, San Francisco. 5. Cable stayed bridge, similar to suspension, but the deck is supported by cables that go directly from the tower to the deck. Increasingly popular in modern construction. Buildings. Buildings are structures designed to provide shelter and space for people and activities. Key structural elements of a building: foundation, the part of the building below ground that transfers all loads to the soil. Columns, vertical members that carry compressive loads from the floors and roof to the foundation. Beams, horizontal members that support floors and roofs, carry loads in bending. Walls, can be structural, load-bearing walls carry load, or non-structural, partition walls just divide space. Slabs, floors and roofs, flat horizontal plate structures that carry the live load and transfer it to beams or walls. Frame structure, a skeleton of columns and beams, steel or reinforced concrete, it carries all loads. Very common for multi-story buildings. Load-bearing wall structure, walls carry the loads directly. More common for smaller, low-rise buildings. Materials used in structural engineering. Concrete, strong in compression. Weak in tension, add steel reinforcement, reinforced concrete. Steel, strong in both tension and compression. Used for tall buildings and long-span bridges. Timber/wood, traditional material. Good strength to weight ratio. Bricks and blocks, used in masonry construction. Strong in compression. Aluminium, lightweight, corrosion resistant. Remember, Structural engineering equals branch of civil engineering dealing with design plus analysis of structures, systems that support plus transfer load safely to the ground. Goals equals strong enough, or can bear loads. Plus stiff enough, don't deflect too much. Plus stable, don't fall over or collapse. Plus durable, last long time. Forces, compression, pushing force, tends to squeeze or shorten a member. Concrete is very strong in compression, tension, pulling force, tends to stretch or lengthen a member. Steel is very strong in tension, shear, sliding force, acts parallel to surface, torsion, twisting force. Loads, dead load, permanent weight of structure itself. Plus live load, temporary loads, people plus furniture plus vehicles. Plus wind load, force of wind against structure. Plus earthquake/seismic load plus no load. Bridges, structure built to span a gap, river plus road plus valley, and carry load safely across. Types, beam/girder bridge, simplest, horizontal beam spans between two supports, beam carries load in bending, used for short spans. Arch bridge, curved arch transfers load to supports in compression, spans greater distances than simple beam bridges. Old stone bridges, truss bridge, framework of triangular units. Triangles equals most stable geometric shape, members experience tension or compression only equals no. Bending, efficient for long spans. Suspension bridge, deck hangs from cables slung over tall towers and anchored to ground. Cables carry load in tension, very economical for very long spans. Golden Gate Bridge, cable stayed bridge, cables go directly from tower to deck. Buildings, key structural elements, foundation, road below ground, transfers all loads to soil. Plus columns, vertical members, carry compressive loads from floors plus roof to foundation. Plus beams, horizontal members, support floors plus roofs, carry loads in bending. Plus walls, load bearing equals carry load, partition equals divide space only. Plus slabs, floors plus roofs, flat horizontal plate structures. Plus frame structure, skeleton of columns plus beams, steel or reinforced concrete, very common for multi-story buildings. Plus load-bearing wall structure, walls carry loads directly, common for smaller low-rise buildings. Materials, concrete, strong in compression, weak in tension. Steel reinforcement equals reinforced concrete. Plus steel, strong in both tension plus compression, tall buildings plus long span bridges. Plus timber/wood, traditional, good strength to weight ratio. Plus bricks plus blocks, masonry, strong in compression. Plus aluminium, lightweight plus corrosion resistant. Thank you for studying basic technology with us today.